Okay, this is a lesson on solving for literal equations. So everything in these equations are all letters. There are no numbers. It's a little more advanced than rearranging formula, but it's worth learning, and it'll make rearranging formula a lot easier if you understand these concepts. So this is normally just the homework that I give students. I do a few examples in class and we work through it together, but I'm going to do this by just asking some questions and then doing the questions, and you should just pause the video, do it yourself, and then see if you get the same result, okay, rather than listening to me go on and explaining, and then it'll be faster. Okay, so let's start with this one. In all of these cases, oh darn, low battery again. Okay, so in all of these cases, I'm solving for the capitalized variable to just make it easier than always having to say solve for x, solve for a, solve for b. Okay, it's always the capital one. Always ask yourself, these are one-step examples, so there's only one thing to do. Ask yourself, what is attached to my unknown? How is it attached? How do I undo that? And then that's what you do. You have the answer to what to do. So, for example, the first one, what is attached to x? A is. How is it attached? By subtraction. How do I undo subtraction? With addition. Then I say, well, do it. Add a to both sides. It'll be gone. You'll get x is equal to b plus a. And hopefully you just go straight to that second step. Next one. Again, here's where you pause the tape and you say, you look at this one and say, what is attached to a? Answer the questions. How is it undone? Do it. See what you get. And then turn on the video and see if you get the same answer. Okay, so what is attached to a? X's. It's attached by multiplication. To undo multiplying, I have to divide both sides by x. That will leave me a is equal to b over x. Next one. What is attached to my b? There's two things that are attached, and they're both attached by multiplication, so I can undo them both at the same time with division. So b is equal to f divided by m squared a. Two-step examples. Here, there could be more than one thing attached to your variable, and they could be attached in different ways. They could be, one's attached by addition or subtraction, and the other is by multiplying or dividing. So you normally have to isolate the term with your unknown in it first before you isolate your unknown. Okay, so here's, again, you can turn it off and figure it out yourself and then check or follow along. I've got C, it's attached to A and B by addition. The way I would undo both of those is by subtraction. So I'm going to subtract A and subtract B from both sides. If I subtract A, it would be gone. If I subtract B, it would be gone, and I would remain with minus C. Now to undo the minus C, remember that's really minus 1C, I would divide both sides by -1. And when I do that, if I divide this by -1, they all change. Negative P plus A plus B. Am I even in the right spot? Yeah, okay. What am I doing? Oh, I skipped some. Sorry. Okay, let me go back up to number 4, sorry. I need to solve for E. What's attached to E? R is, it's attached by division, so I'm going to undo it by multiplying both sides by R. IR will equal E. Number 5. I got two things attached to P, both by multiplication. I can undo them both by division. Divide by RT. If I divide this by RT, I'll be left with P. Last one, I'm trying to get B by itself. It's attached to two things, both by addition. So I'm going to leave it where it is. I'm going to subtract the A and subtract the C. That's how I get rid of it all. Okay, sorry, and then I skipped over to the two-step examples. Again, so I'm trying to get this. So this is a term with D in it, and I need to get the term by itself, meaning minus 3D. I need to isolate that before I try to get D. So minus 3D is attached to 2C by addition. So I'm going to subtract 2C from both sides. Okay, subtract 2C from both sides. Now I'm going to divide off the coefficient, leaving d is equal to. Now remember, you have to put that fraction bar all the way across because the entire side is being divided by -3. Okay, so, ooh, I don't like this. I don't like that fraction written like that. So remember, from our unit, I'm going to write that as z over 2. That makes it a little nicer. Now, I'm not going to necessarily clear denominators, but I could. You have two options. You could either put these both over 1 and then clear denominators by multiplying everything by 2. That is one thing you can do. Or you can, I'm going to just put this on here so I know it's a z and not a 2. Or you can isolate the term with z and then isolate z. So I'm going to do it that way. I'm going to add t to both sides. We'll isolate my term with z. And now I can see z is being divided by 2. To undo divided by 2, I multiply both sides by 2. And you don't leave an answer that's unsimplified. So I'm going to distribute the 2 through and get 6w plus 2t. That's what z is, 6w plus 2t. Okay, number 4. So hopefully you're recognizing you basically undo adding and subtracting first and then multiplying and dividing second. Okay, order of operation is you, BEDMAS is you're going to do multiplying and dividing before you do adding and subtracting. And so when you undo things, you have to undo it in the reverse order of BEDMAS. So we're going to subtract b from both sides to get rid of the b. And then I'm going to see that a, I got to get rid of that divided by a by multiplying both sides by a. Let's see if you can follow this. I'm going to multiply both sides by a. So rather than writing a bracket c minus b, I'm just going to know that I'm distributing to both right now. So I'm going to write either this, well, actually do this, ac minus ab. It is okay also to write this. And you could sometimes leave that. You have to see what your teacher wants. It can be fine to leave either. Number 5. Okay, I need to get t. Now I got to isolate this thing first by getting rid of the p, and then I can go after the t. So a minus p equals prt, and then I'm going to divide off the pr. Next one. Again, you should be pausing the tape between each one and attempting it yourself first, and then trying it and see if you get the same answer. Okay, so I need to get that big A. So this is the term with A. I'm going to leave it where it is. I'm going to get rid of the u squared first by subtracting it off. I need to leave the A. It's attached to 2 and s, both by multiplying, so I'm going to divide both sides. I use a cursive S usually so that I'm not confused into thinking it's a 5. And then this answer doesn't change. I just rewrite it. Okay. Oh, goodness, lots of them. Okay, so these are all here just for practice because this is the homework, like I said. It's a crazy long lesson otherwise, but write it like this. Write fractions with the bars going all the way across. And then I'm going to multiply both sides by 2. And I'm going to divide both sides by b. That's what h is. 2a for b is h. Sorry, that's getting squishy. 2a over b is equal to h. Next one. L. Multiply both sides by d squared. Okay, sorry. KL has d squared attached to it by division, so undo division with multiplication. And then I'm going to undo times k with divide by k. And I just, rather than write it like that, I'm just going to write divide by k over here and know that I've got that. It's going to save me this kind of mess. Where am I? Okay, number 9. Okay, so I'm going to I'm going to see this whole thing is all multiplying and dividing with L, and then subtract B. I can't get these things off until I get rid of that B first by adding. So first, get rid of the B by adding. Now, if you're ready, you can see that I've got L is attached to two things. It's attached to K by multiplying, and it's attached to D squared by dividing. So I could multiply both sides by D squared, and then I could divide both sides by K to get L by itself. It's easier than doing it in 2 steps, if you understand. Instead, just multiply by the reciprocal. You want to get rid of the D squared by multiplying, and you want to get rid of the K by dividing. So just do both at the same time. Okay, so then you're gonna see here the K's will cancel, the D squareds will cancel, and you'll be left with L. And on this side, you can either extend that bar all the way across and you can leave that as an answer, or you could distribute through the top D squared R plus D squared B all over K. Either one of these is fine. I would put the bar across though. Okay, next one. The thing you're looking for is in brackets. So, 2 approaches to this. One is isolate the bracket by dividing off whatever's multiplying or whatever's happening to the bracket. So I could divide both sides by P to isolate the bracket. And now I don't really even need the bracket since it's isolated. So I wouldn't bother writing that. And now it's the same as before. I'm going to isolate the term with the T by subtracting X from both sides. But here's the tricky part. I got a fraction and a non-fraction, and I have to divide by R to get R off of the T. But that's a little bit tricky. So it's easy because I'm going to get like a big division and then it's a little confusing. The easiest way, when you have fractions involved, the easiest way to divide by something is instead to multiply by its reciprocal. Multiply by its reciprocal. It's the same thing. Remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So we're not doing anything new here. That will isolate T. And it'll make it a lot easier for you to realize that this is, if you distribute through, it's I over PR, subtract X over R. Okay, you're distributing this through. I'm going to go onto the back. Actually, I'll go onto the back of the sheet. Onto the back of the sheet. I'm going to redo this question a second way. I equals P times X plus RT. Okay, if you really hated that way of doing it, there is another way. You could distribute this P through the bracket. And then you can isolate the term with T by getting rid of whatever's being added to it. And then you can isolate the T by dividing off the PR. Okay, this answer is actually the same as this. It's the same answer. It's a little confusing why it's the same, but it is the same. You can see here that the denominator, PR, is the same as this. RP, PR, same thing with an I. If I wanted to subtract this fraction from this, I would need a common denominator. And since this denominator is R and this one's RP, this one's missing a P. So I could multiply the top and bottom of that fraction by P. And now that I have the same denominator, which I'm going to call PR, then I could group the tops by subtracting them. I'm just rearranging XP to PX. And now you can see that it's the same answer as doing it that way. So although sometimes presents the answer a little differently. You can have the correct answer and have it look a little different than your friends. And if you understand, common denominators with fractions, which hopefully you do, although it's a little more complicated when it's all letters, you can see that the answers are indeed the same. Let's go back to number 2. Again, let's try this one a different way. We see that fraction. Let's say, hey, let's extend that bar. Let's clear fractions. Let's multiply everything by 2 so we don't have a fraction, because we know we're allowed to do that. This is where you start to get creative and thinking of what way you would like to solve it first. That makes more sense for you, because there's multiple ways. Okay, now that I don't have any fractions, I'm trying to get c by itself. I'm going to either divide off the h off both sides and then subtract b, or I could distribute the h through and then do it that second way. I'm going to divide by h. And then I'm going to subtract b. Okay, so what I just did there was when I got to here, I cleared, and then I kind of thought ahead. I thought, okay, I could divide by h, and then I would be subtracting b. And I saw that that's not that hard. And so I thought I'll do that. Or over here, if you had a thought, okay, I'm going to divide off by p, and then I'm going to subtract 8x, and then I'm going to have to divide by t. That's starting to sound a little complicated. So that type of situation might be one where you say, hey, instead of doing that, I'm going to distribute, because then that's a lot easier for me. That's like just looking ahead and seeing if you understand where you're going next will help you pick a better plan for yourself. Okay, so we need to get r by itself. It's attached. These are all very similar. It's attached to something else. I'm going to see that if I divide by this, I'll be left with r plus h, and then I just have to subtract h. So that's not hard to do. Divide both sides by 2 pi r. That will leave me r plus h. And then I get a over 2 pi r. Subtract h is equal to, equal to r, capital R. Notice I have 2 r's in this question, but one's lowercase and one's uppercase, so they're different. And this should be looking like something to do with a circle. 2 pi r, That's rearranging formulas. Okay, next one. Let's keep going. So I'm just going to, again, you try it first. I've just introduced some division here as well. So I've got divided by f. Let's clear that by multiplying both sides by f. Okay, and now it's the same as what we were just doing before. I can either distribute through and subtract, but I think now I'll divide. And then I'll add the r. To get to the answer. The next one, I'm going to say, ooh, I really don't like that. The thing I need is in the top. This whole thing's on the bottom. I'm going to clear the fraction by multiplying both sides by all of this. That whole bottom I'm going to multiply. Because this whole thing that I kind of like to get by itself is being divided by all of that. So I'm going to multiply both sides by all of that. F minus r. Oopsie. Okay, it would cancel away, leaving just the numerator. Now I'm going to divide off by v. It would cancel, leaving just p minus r. And the next step, I'm going to add r to both sides. If I added r to this side, I'd be left with p. If I added r to that side, I'd be left with this little bit of a mess. But that's fine. And the last one, n is in there. All of this I need to get by itself by subtracting a. And then it's d, the thing I want is n. I'm going to divide off by d because it's by multiplying, so I'm going to divide it away. It's gone, and then that leaves me with n minus 1. And to get n by itself, I need to add a 1. So I'm going to get s minus a all over d, add a 1, will equal n. Subtract 1 plus 1, which is gone. Okay, now we're on to section D. The thing you're looking for is in more than one term. This is very tricky, and it requires It's quite tricky, but let's try it. This might be more advanced than what you have to know in grade 9, but I think you can do it. So we need to find y. It's in 2 spots. So we need to group the y's together. We need to think of this as 3cy and a cy. I'm going to subtract cy from both sides. 3cy subtract cy is equal to d plus b. I'm going to move that b over there by adding b to both sides. And I'm going to get rid of the cy by subtracting it from both sides. So now I got the y's both on one side. So this is kind of like having 5y's subtract 2y's would equal 3y's if I knew how to subtract that. So I just know that the way I figure out how many y's I have is I would just take the coefficients and subtract them. So I've got 3c minus c. Sorry, I'm saying something not very good here. I thought it was harder than this. 3cy's subtract cy's. They both kind of have a variable of cy. So I've got 3cy's, take away 1cy equals 2cy's. That was pretty tricky. And so, but they're like terms. And then I can isolate for y by dividing off the 2c. Okay, the next one. H is what we want. If you were to distribute the h through, you'd create a very hard problem for yourself. So even though that worked really well up there, it doesn't work if the thing you're looking for is the thing you're distributing through. Don't distribute the thing you're looking for through. Instead, divide both sides by a plus b. That's how you isolate the thing you're looking for. And the last one is really hard. If you have xa's and you subtract xb's, you're going to get c. The problem is x is in 2 places. You have to do something called factoring. And this you haven't learned yet. You can see that you have it's kind of like reversing. It's kind of, I'm going to do it 2 ways. One is, it's kind of like having ax's subtract bx's. Well, if those were numbers, like a 5 and a 2, you know that the way you find out how many x's you have is you simply subtract 5 take away 2. And you would have 3 x's. So here you'd have a take away b. That's how many x's you'd have. You'd have a subtract b x's. If you notice, what you've really done is you've factored. You recognize that if you distribute the x through, you get this. So I'm just bringing the x out instead. Equals c. Now I can divide off by a minus b. If you don't understand the questions in D, don't worry, because they're a little higher than what you have to know in grade 9. Okay, but once you learn factoring, you'll be able to do this. E, x is in the denominator. Again, the easiest way to do this is to simply multiply both sides by the denominator, because that's what you do when you clear. So you could clear denominators by multiplying. It seems weird to multiply by the thing you're looking for to eliminate it, but what's going to happen is on this side r is going to disappear, but it's going to end up on that side. So although you're canceling what you want, it is showing up on the other side, so you haven't really gotten rid of it. And then you can isolate for r. Or you could cross multiply. Think of that as a 1, do the same thing, you get the same result. Or think of reciprocals. That would be 1 over I equals r over e, right? Because the reciprocal of any number is just 1 over that number. And then you could multiply both sides by e to isolate the r. So you'd have e times 1 over I equals r, which is e over I. So all different ways to think about it, get to the same answer. Last one, it's taking forever. Okay. Again, just multiply by r to get it out from the bottom of the fraction. Would cancel here, but it's over here now. And then divide off the c. Let me see. Ta-da! All done. Now, if you found D and E really tricky, don't worry too much about that. That's really a little more advanced, but worth a shot learning it. But you should be able to do the stuff up to here, okay? And that's the end of that.